All right, let's start taking notes. Last time we had stopped at rapid movements under mass movements. So we are talking about mass movements, right? Under this, let's take notes on rapid movements. Okay. So take notes. Rapid movements. Mostly prevalent in humid climatic regions and occur over gentle to steep slopes. Okay. So what are these types? Types is first is earth flow. So under earth flow, it's if I'm writing fast, please let me know over the chat. We'll slow down. Movement of water saturated clay or silty earth materials. Earth materials down the low angle terraces or hill side. In case of steep slopes, even the bedrock may slide. What is bedrock? Bedrock is unweathered rock. The bedrock may be sedimentary rocks or sedimentary rocks or igneous rocks. Okay. So water saturated underline and earth materials. The earth materials, not like mud and all. Right? Earth materials, big stones and all, that kind of boulders or something. All right. So next is mud flow. Right? Take down movement of water saturated thick layers of thick layers. See, thick layers of weathered materials, whether thick layers of weathered materials. Here it was earth materials. These are weathered materials. Yeah. So you should know the difference. That is where they'll try to trap in questions. Weathered materials down. See, definite, okay, definite channels. It is mostly due to heavy rainfall or loss of vegetation. Okay. So it may be slow or rapid. So slow is relative sense, not don't consider it as a slow movement, right? It's rapid movement only, relatively, but so in both in relative to avalanches and all, right? When mud flows emerges out of channels to plains, it may be very destructive. It frequently occurs in slopes of erupting or recently erupted volcanoes. Volcanoes is important. So volcanoes, anything related to volcanoes is very important from the exam perspective, right? So which is the common type of mass movement observed in volcanoes? They may give four options: creep, okay, solifluction, okay, earth flow, mud flow, avalanche, right? So if you, I mean, if you have half knowledge, people might go for avalanches. Right? If you have no knowledge, then people might get confused to opt at all or leave the question. Or if you have the full perfect knowledge, it is about mud flow. Mud flow is very important. I'll tell you why it's very important. So, so usually the concept came from volcanoes itself, the mud flows. Let's say, for example, take down Mount Vesi, Vesu, Vesuvius, Mount Vesuvius, Italy had buried its, okay, Pompeii, Pompeii town. Very devastating in nature, right? So why very devastating in nature? Because the Mount Vesuvius is the most volcanic active mountain in Italy, in fact, in the whole world. Okay. So one time it came so much volcanic eruption, so the whole Pompeii town was buried. So contrary to our understanding, right, we might understand it was due to the lava which has flown out and has buried the town. But that may be true a certain extent. But the real reason, for example, in geography, there will be multiple reasons for an activity to happen, event to happen. So volcanic lava may be one of the reasons to bury down the Pompeii town, but the main reason was the mud flows. When this volcano happened, right, there was too much ash, Okay, the mountain itself, the town Pompeii town, which is lying towards the foothills of Mount Vesuvius, had actually removed the vegetation for its agricultural purpose. Right? A lot of settlement had happened, and then there was a lot of loose mud, unsolicited rocks. Okay, and along with this lava which heated these rocks, there was crystallization of rocks, breakage of these rocks, and lava itself added too much of ash, and there was heavy rainfall. All this together made this mud flow to happen so much to extent that it was like several feet high from the ground, and it completely buried the town. So this is the biggest event in the human history. Right? It completely buried the town. For example, for instance, God forbid, and the whole of Tumkur is buried, for instance, or something like that. The whole of one of the areas, say Nandi Hills, the foothills of Nandi Hills, we have like Dodbalapur or something like that. You imagine the whole of Dodbalapur is buried. It has happened. Pompeii was a very big town. Right? So these kind of devastations, from this only the concept came as mud flow. For example, anyone who talks about volcano and mass movements, you should be aware of, they're talking about not landslide, they're talking about mud flow. Okay, and upside. Let's take a notes of one more thing, avalanches. So the third type of rapid movement is uh, avalanches. So usually in Himalayan regions, occurs in humid regions with or without vegetation cover. Without, with anything. So which see for mud flow, removal of vegetation cover is a accelerator, enhancer for that. But for avalanche, it doesn't matter which stage because the kind of force it comes down, right? One trees can stop to a certain extent. Right? Beyond that extent, even trees cannot stop. That's what it meant. So avalanches occurs in that's the difference between avalanches and mud flow and earth flows. Mud and earth flows, if you have vegetation, we can stop it. Right? For example, there will be an option. How do we actually stop avalanches from causing destruction, plantation of trees in its track? No, it doesn't have work out. So that option should not pick up, right? So we might have a vague understanding. Okay, trees might stop the avalanches and all. No, question is, if you know the basics, trees cannot stop the avalanches. Okay, this kind of we should know the differences. Occurs in narrow tracks on steep slopes. This debris avalanches are much faster than mud flow. Much faster. So again a question. As I said in last class, right? The fastest rapid movements is avalanches among mud flow and earth flow. But the most destructive is mud flow, even though it's slower than avalanches. Because why? Because mud flow happens usually where human habitations happens. So we should not forget the human dimension or human angle of answering the questions. So avalanches happen in there is no human settlements, right? So mud flow happens because human settlements, if they're there, they will cut down the trees, etc. So this will enhance the mud flow activities. Those are interrelated. So, so not audible, is it? Am I audible? Okay. Okay. Thanks. Maybe Kavya, audible now? I think Ganesha respond is okay. Others can listen. Okay. Fine. All right. So these are for the notes. So much so. Uh, okay. So maybe Kavya, you might need to check your audio. All right. So let's get into the last topic of the mass movement, that is avalanches. So this is a, I'll give notes later. So let understand this one. So sorry, landslides. Okay. So landslides are also rapid, right? So rapid means perceptible movement. So people can see the landslide happening, right? Unlike creep, which people cannot see the landslide happening unless the pole is bent, a tree is bent, something like that. So landslide is a rapid movements. Okay. So how it is different from avalanches or rapid movements, right? See, landslide is not one of rapid movements. For example, rapid movements engages humid climatic regions, but landslide are rapid, but they happen in relatively dry regions. This is the most important keyword you should be aware of. Landslide happens in relatively dry regions. Avalanches, mud flows, earth flows happens in humid conditions. Fine. I hope the people will remember this. Okay. The size and shape of the detached mass. So landslide is very specific. So very specific in the sense we are concerned with mass, rock mass. Okay. So we're concerned with how the rock mass are getting detached. Was we concerned this way in other moments, slow or rapid moments? We don't know. It's something avalanches, some we generally termed as a debris. Debris used to slide away and fall away, and we don't have to worry about. All we had to worry about in rapid movement is how fast it was, how destructive it was, what are the causes for it to movement. But landslide comes to landslide, we are a little more specific on what is the shape of the debris being detached. Okay, so we are worried about shape and size of detached mass. We're not even called about debris, right? So so that depends. So depending upon, so this shape and size might depend upon the slope, right? What is the gradient, right? Or it might go upon material type. What is the material type? Sedimentary or igneous, something like that. Right. So let's say, so why are we worried about the shape and size of the debris? Because landslide, not only the mass gets detached, but the mass also forms a different landform altogether. Right? Imagine we're always interested in the landforms, the shape of the landform being formed. For example, there are something called, there are three types of landslides. For example, based on the detached mass and the shape it forms up. There's something called slump, fine, and something called debris slide, and something called rock slide. Fine. Pay attention. So these are the three types of land slide. So rock slide is a landslide. It's not a rapid movement, right? A mass just gets detached and it slides along the rock bed along the slope. All right. So what is slump? So slump is nothing but the rock debris with a backward rotation with respect to the slope. So what is the backward rotations? For example, let's say here is your original land like this. This is a slide is there. Fine. So this is the original land, right? Reverse slope of the rock debris, backward rotation with respect to slope. So this is the slope, right? This whole land slides in a way that it rotates backward. This whole thing rotates like this. This was the original, and this was the rotation. So for example, this is the line. See, this is the line, right? This is the line. How it has come, it has rotated backwards. For example, if there was a tree here, how would it have been looked? It would have looked like this. So this is slump. The whole landmass or the landslide rotates backwards. If it doesn't rotate backward, I hope you understood the concept. If it is rotate backwards, it will be same way. It will just slide down like this. Right? There is no black, but the whole thing will be straight and slide out. If there's a tree like this, it would be partially be like this, or it may be straight. Straight is rare, but it would have been naturally slided down. The new landform would have formed. So what is rock slide? Right, rock slide. You have seen many of the videos. There is a steep mountain, right? Especially near the water areas like sea, right? If there is a rock like this, right, the whole rock falls into the sea. This is a rock slide. So nowhere there is no like minute particles like mud or some avalanche debris falling in very, very minute particles, right? It's the whole big mass of land just slumping down, say reverse back with the backward rotation, or without backward rotation, there's a debris slide, right? And there's rock slide, this whole rock mass is falling down the steep slope. Okay. So these are the types of um, landslides. Right. Let's say we have one more, yeah, take the notes for this. Let's wind it up. I hope you're clear. So there are slow movements, rapid movements, and landslides. Maybe it's something. It may be rapid part of. It may be called the movements are very rapid, but only thing with difference with rapid movements is it is dry, relatively dry. Okay, let's say landslides and cover this topic and notes together so that we are out of mass movements. From tomorrow we can start a new topic, erosions. Okay, landslide. They are relatively rapid and perceptible movements. The materials involved are Ideally dry. Mhm. The size and shape of the detached mass depends on nature of discontinuities in rock and rock materials. Depending upon type of movement, depending upon type of movement of materials, take one thing, one slump, okay, it's something else, slipping of one or several units of direction. I'll go back. Want one more back, is it? This is the one. You want me to stop there? Yeah, let me know once done. So I'll proceed. Okay, I'll proceed. Thanks. Right. Slipping of one or several units of rock debris with backward rotation. Rotation with respect to slopes. Okay. With respect to in mains exams, I hope people will not write. They won't tolerate abbreviations. Just for our notes, we can keep. So take down a picture. This is original, right? I know you might not be having the color and all. This maybe in black pen only you can try to uh, make it more significant. So it lock slump will happen like this. This tree might help you. This is after slide. Okay. Next. Debris slide. Same. Rapid sliding of a rock debris without backward rotations. And third is rock slide. See, this is sliding of individual rock masses down bedding joint or fault surface. Rock fall in free fall mode over any steep slope. Right. This ends the notes on the mass resting. I hope you people can revise the complete notes today. Okay. So tomorrow we'll start with erosion.